Hi, this is Mr. Nazarian. Our lesson objective today: I can solve real-world problems involving multiplication and division of fractions and mixed numbers. It's 5th grade standard, numbers and fractions 6. McKenna has 6 orange juice containers. Each container is 1/3 full. McKenna says that she has a total of 4 gallons of orange juice. Which of these statements must be true in order for McKenna's claim to be true? A. Each container has a capacity of 1/3 gallon. B. Each container has a capacity of 2 gallons. Or C. Each container has a capacity of 1 gallon. So, first of all, we want to know the question, right? Always want to know the question so we can kind of stabilize ourselves and get some footing here. We want to know which of these statements must be true in order for McKenna's claim to be true. Well, we need to go back to what's her claim. Her claim is that she has a total of 4 gallons of orange juice, right? So we know that in our calculations, we want to make sure that the total amount of orange juice that she has is 4 gallons. One of these statements is going to bring us to that reality. Then we're looking at other facts that are going to help us solve this problem. We know that each container that she has is 1/3 full. We don't know how big the containers are yet, but we know that each one is 1/3 full. And we know that she has 6, I'll just circle this part. She has 6 containers, right? So 6 containers, each of those containers is 1/3 full. We need to figure out what's the size of each of those containers. That's what we mean by capacity. So the only way that we can solve this, or a really great way to solve it, would be to just test out each of these. Just like guess and check is a really great strategy to use. We already have the guesses here. We know that one of them is correct, so we're going to go ahead and plug in each of these amounts to figure out which one is going to work. So we're going to start with, container A. So we're just going to head on down. So in situation A, each container has capacity of 1/3 gallon. So the whole container itself would be 1/3 gallon if it was all the way full. And we know that each container is 1/3 full. So we're going to first look at option A. So in option A, each container is 1/3 of a gallon if it's all the way full, right? If it was all the way to the top, this would be 1/3 of a gallon. However, something that we know that is true is that each of these containers that McKenna has is 1/3 full. So this 1/3 of a gallon full container is actually only 1/3 full here. So we're looking at what's 1/3 of the 1/3 gallon. So we're going to multiply them, right? Because we're finding a fraction of another fraction. We're going to multiply those fractions together, and that is going to give us 1/9. And I've kind of moved through these steps kind of quickly because I know that you guys are all stars at multiplying fractions. So that means that in this one container, she's going to have 1/9 of a gallon, right? Because a container all the way full would be 1/3 of a gallon. She has 1/3 of that, so that would give us 1/9 of a gallon here for one container. However, she has 6 containers. So we have to multiply that 1/9 of a gallon by 6, and that would give us 6/9 of a gallon. Now remember, she claimed that she had a total of 4 gallons, which means that 6/9 is obviously not 4 gallons. So that means A does not work. All right, so we are going to look at the next one. So in choice B, statement B, she has a 2-gallon size container. So that means that the whole container itself would hold 2 gallons, right? 2 whole gallons is a big container. And remember that each container is 1/3 full. So we would take just 1/3 of the 2 gallons, which means if we're taking 1/3 of it, we're multiplying 1/3 times 2. That would give us 2/3. And that would just be one container, though. We know that she has a total of 6 containers, so we would say 2/3 and 2/3 and 2/3 and 2/3 and so forth. So we have 6 containers that are 2/3 of a gallon. That would give us 12/3 of a gallon, which is an improper fraction. 12 divided by 3, it gives us 4. And 4 is how many gallons she claimed to have. So that means, ding, 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 that this statement would be true. Now, using reasoning, we would know that, well, if the 2 gallons worked, then obviously that's it. That's the only one that's going to work. But just to make ourselves feel more confident and make sure that it doesn't work, we can always do this step further through. It doesn't hurt. It's extra practice. So if we did 1 gallon containers, 1/3 of that would be 1/3 of a gallon for each container, times 6 containers would give us 6/3, which would be only 2 gallons. So option B is the only one that works. And that is how you solve these kinds of problems. We're going to work more on solving these kinds of real world problems tomorrow. See you then. Bye.